Good morning, student. I'm Subham Chaudhary. In this session, I will discuss about properties of integers. In last session, I discussed about closure property of integers under both addition and subtraction. Now, in this session, I will discuss about commutative property, associative property, and additive identity for integers. Now, student, what is commutative property? Now, see, suppose A and B are two numbers, and after adding A plus B and B plus A, if in both the cases, if we get same result, then we say that it follows commutative property. Similar in case of multiplication. If we do x into y and y into x, and in both the cases, if we get same value, then we say that it follows commutative property. Now, commutative property for addition. We know that 3 plus 5 equal to 5 plus 3 equal to 8. That is, the whole numbers can be added in any order. In other words, addition is commutative for whole numbers. So we can say addition is commutative for whole numbers because here if you see the example, here both 3 and 5 are whole numbers, and after doing 3 plus 5 and 5 plus 3, in both the cases we got 8. So we can say that addition is commutative for whole numbers. Now student, can we say the same for integers also? Okay students, let's check it. So students, you are asked to calculate it by stopping the video, and after calculation you can resume it again. So okay, after calculation, students, please check your answers. So if you observe it in statement 1 and statement 2, you can see that in both the statements the results are same. That is, 5 plus minus 6 equal to minus 1 and minus 6 plus 5 equal to minus 1. So what we did, we have just changed the order of numbers. Similarly, number 2, minus 8 plus minus 9, and in second statement minus 9 plus minus 8. And in both the statements results are same, minus 17 and minus 17. Similarly, in third statement, minus 23 plus 32, 32 plus minus 23. Again we change the order and we get the result same. Similarly for the others, minus 45 plus 0, 0 plus minus 45. The result is same again, minus 45. Followed by 23 plus minus 17 equal to 6, minus 17 plus 23 equal to 6. 89 plus minus 89 equal to 0, minus 89 plus 89 equal to 0. So if you see it carefully, what can you say that? You can say that in both the statements we are getting same result. Now let's see commutative property for subtraction. Now students are asked to stop the video and calculate it, and after calculation resume it again. Now student, check your answers. Okay, now if you check it carefully, 3 minus minus 2 equal to 5, and minus 2 minus 3 is equal to minus 5. Minus 8 minus minus 7 equal to minus 1. Minus 7 minus minus 8 equal to 1. So basically in statement 1 and 2, if we change the order of the integers, we are not getting the same values. Same in all the cases. See students, 3 minus minus 2 in the statement 1, and in the second statement minus 2 minus 3. So we have changed the order and after changing the order we didn't get same value. In first statement we got 5 result, and in second statement we got -5 result. Again in the second one -8 -7, and in second statement -7 -8. Again we changed the order but we didn't get the same result. Similarly for all the cases, 16 minus -5 -5 -16. If you see, we have not get same result. 3 minus 12, 12 minus 3. 3 minus 12 is 9, -9, and 12 minus 3 is 9. 9 and -9 are not same. Similarly, 0 minus -15 is 15, -15 minus 0 is -15, which is again not same. So student, what can we say? We can say that this property tells us that sum of two integers remains same even if order of integers is changed. If a and b are two integers, then a plus b equal to b plus a. Because student, we have seen here that after changing the orders we got the same result for addition, and we have seen here that after changing the orders we didn't get same result for subtraction. So because for that reason only we can say that commutative property of integer is satisfied under addition, but commutative property of integers will not satisfy under subtraction. Because student, subtraction of two integers is not commutative. If a and b are two integers, then a minus b is not equal to b minus a. There is one example for you student. You can see 4 minus -6 will not be equal to -6 minus 4. We have seen many examples here. So students, we can say that commutative property is not followed for integers under subtraction. Now students, there is one more property for integers, is associative property. So student, what is this property? It is the way in which three or more terms are grouped and does not change the sum. Suppose, for example, in bracket a plus b plus c equal to a plus within bracket b plus c. If in both the statements, if we get same result, then we say that it follows associative property. Okay students, let's check it. Students are also again asked to calculate this and then check your answers. Okay students, check your answers now. So in the statements, if you see, in both the statements we got same result. See student, in first statement -5 plus within bracket -3 plus -2, and in second statement within bracket -5 plus -3 plus -2. So in both the statements we got same result. Similarly, in the other cases also we get the same result. -3 plus within bracket 1 plus -7, and in second statement we have changed the order of the bracket. -3 plus 1 in bracket plus -7. So again in both the statements we get same result, and followed by the others. -7 plus within bracket 5 plus 9, which is 7, and within bracket -7 plus 5 plus 9, which is again 7. And the last one, 15 plus within bracket 12 plus 8 equal to 35. Again within bracket 15 plus 12 plus 8 equal to 35. So associative property is what? So what basically we do in associative property, we change the position of the brackets. See student, here the bracket is with a plus b, and in second case the bracket with b plus c. So after changing the position, if we get the result same, then we say that it follows commutative property. So we did the same thing there. We have changed the bracket position of the bracket and we get the result same in all the cases. So students, what can we say? This property tells us that we can group integers in a sum of any way we want and still get same number. So addition is associative for integers. In general, a plus within bracket b plus c equal to within bracket a plus b plus c. For example, 2 plus within bracket 3 plus 4 will give the same value for within bracket 2 plus 3 plus 4. Now student, associative property will not follow under subtraction, because student, if you see the example 3 plus within bracket 5 minus 7, the result will be 5, and within bracket 3 minus 5 minus 7, the result will be minus 9. So for this case, we say that student, associative property is not followed for integers under subtraction, but students, associative property for integers is followed under addition. Okay students, now here comes the last part of this session is additive identity for integers. So students, what does additive identity for integers mean? Okay, when an element that when added to a given element in a specified set leave that element unchanged as 0 in real number system. A simpler way to say it means that you can add 0 to any number and it keeps its identity. The number stays the same. So additive identity means the number which added to a given number and gives the result same. Then we say that number as the additive identity of the given number. Suppose student, your one number a is given. Now if you add b with a and you get equal to the result a, then we can say that b as the additive identity for a. So what I basically said is, when we add 0 to any whole number, we get the same whole number. So 0 is an additive identity for whole numbers, because we know that 8 plus 0 is 8, 13 plus 0 is 13, 17 plus 0 is 17. So if we add 0 with any whole number, we get the same whole number. So we can say that 0 is an additive identity for whole number. Now is it an additive identity for integers also? Okay students, let's check it. If you see, there are 6 examples given. Minus 8 plus 0 is minus 8. Minus 23 plus 0 is minus 23. 0 plus minus 37 is minus 37. Minus 59 plus 0 equal to minus 59. 13 plus 0 equal to 13. 0 plus minus 19 equal to 19. So what we can see from these examples, when we add 0 with a integer, we get the same integers. So student, what we can conclude that adding 0 won't change a number. When 0 is added to a number, the result is the number itself. So we can say that 0 is additive identity for integers also. Thank you, students. If you have any doubt, you can ask. Thank you.